Okay, today we shall see NoSQL systems, not only SQL systems, as I was mentioning in the previous hour of our discussion about the types of data, the types of database systems, how data has evolved from relational database management system to the current heterogeneous, unstructured type of data. How to handle such data is a big question. Thinking about data from social media, data from search engines, data from stream of data from various computing, scientific computing applications. There is a need of system which will handle a stream of data instead of keeping them in a relational database model. How do we Am I audible now? Hello?
Yes, sir.
Okay. Yeah.
Yes, sir.
There was some glitch in the power connectivity and the network connectivity. So let me start again. Hmm? So not only SQL system came into picture in the during the 1998 when internet evolved and lot of data generated based on search engine logs as well as later social networking came into picture. Then from there also a lot of data has been generated. So instead of handling these data using SQL queries, people started thinking about any other method of handling data using either Unix shell scripting, because Unix file system works on the basis of file system. Everything is considered to be a file. So it is easy to handle any file using Unix shell scripts. So people started thinking about developing shell scripting for handling files. Okay, so that was the main reason when SQL or not only SQL came into picture. Two main factors have determined the growth of the NoSQL or not only SQL movement. In many cases, simple data models are enough to represent the information used by applications, and the quantity of information contained in unstructured format has grown considerably in the last decade. So the data, whether it is in the unstructured or structured format, based on that, certain database model need to be selected for proper handling of data, because there may be a redundancy of data, there may be inconsistency of data, there may be duplication of data. So all these things need to be handled. For that, you must have a proper database management system. So if the data itself is unstructured in nature, how do we really handle that? So based on this criteria, NoSQL came into picture. These two factors made software engineers to look to alternatives that were more suitable to specific application domains they were working on. As a result, several different initiatives explored the use of non-relational storage systems, which considerably differ from each other. So non-relational model. So non-relational. See, in a relational model, the attributes and the tuples, the values and the attributes have got some relations, because you will have multiple tables. Each table will be related with some of the attributes. So attributes will be used there to handle data. Maybe some of the tables also merge to get a single view. All that you can recall from your relational database model, which you have studied in the previous semester. Recall them, and you can understand this better. A broad classification is reported by Wikipedia, which distinguishes NoSQL implementation into document stores. So it is also available in page number 8.10 of the regular textbook. Document stores: Apache Jacrabbit, Apache CouchDB, SimpleDB, TerraStore. These are the document stores where a lot of data is being saved. Graphs. Okay, there are some companies where the data, graph data is being saved. Multi-value database: OpenQM, Rocket, U2, OpenInsight. Object databases: Object Store, Jade, ZODB, tabular stores: Google Bigtable, Hadoop, HBase, Hypertable. So tabular data, which we will be discussing with Google Bigtable as well as Hadoop for HBase in a due course. Tuple Store, Apache, River. So these are some of the NoSQL or not only SQL implementation which are very popular in the field of data handling or data mining or data analytics. Apache CouchDB or MongoDB we will see in detail. Okay, MongoDB is and Apache CouchDB. Apache, you know what is Apache? Apache is a web server. Is a popular web server in open source web server, which will normally Apache will work also with MySQL, simple MySQL. So with the relational database model, you can use with a MySQL. Non-relationship model, so you can go with a CouchDB or MongoDB, which will be supported by Apache. So Java will also support along with JSON, and RESTful also it will be used. Okay, both provide a schemeless store. Scheme is not there. See, schema-less. Okay, scheme will not be defined for any data. Schema will not be defined for any data. So schema means how data should be saved. The structure of data will be defined in the schema. Schema will not be there. Schema-less store whereby the primary objects or documents organized into collection of key value fields. So you can think of associative list. So there will be a key, there will be a value. Key and value will be paired together to keep the values. The value of each field can be type string, integer, float, date, or an array of values. You can recall one more language is there which will handle similar type of data is the Lisp language currently, which is not there in your syllabus. But anyway, if you get some time, you can understand the importance of Lisp for natural language processing. As we said already, AI and data mining, AI and natural language processing are the hot area where cloud computing is also combined into this, you will have a lot of opportunities of handling natural languages. So you can think of understanding those concepts also. So Lisp is one language where everything will be saved as a list of data. Similarly, here also, Python also supporting now. Python is also supporting Java also, certain level it will support. Okay, so database exposed to RESTful interface as well as it is represented in the JSON format. So anyway, the data is should be in some format, not in a relational table or relational database model, but it should be in some format to read the data, send the data. Sometimes this XML format is also used for sending data, as I already said in the previous classes. So you should know the data, how data is transmitted, what are the different types of data available for keeping in a document. So type of string, integer, float, date, an array of values will be saved in the form of files. Both allow querying and indexing data by using the MapReduce programming model, which we are going to discuss very shortly. MapReduce programming model. Map and reduce. So mapping is so there are two major operations in map and reduce. Map the data to subkey and later collect all the keys which are key and values which are similar or same or identical, and then combine them together. That is a reduction operation. We will see some examples related to this in the next hour. Map reduce programming model expose JavaScript as a base language. Say, as just now I said, Java is a supporting language for handling. So JavaScript is reduced or derived from Java only. So JavaScript is a web-based language also. So web scripting can be written in Java. So that is a JavaScript. So JavaScript is a very good tool for handling such data, and you can use it for data query and manipulation. No, instead of SQL, JavaScript can be used. Okay, I think you have already started developing some JavaScript program in web programming laboratory. You can do this also, and large files can be handled using JavaScript. Okay, so that's what about Apache CouchDB and MongoDB. Now next one is Amazon Dynamo. Dynamo is a distributed key value store. Again, underline this, it is also key value store that supports the management of information of several of the business services offered by Amazon Inc. So Amazon is using as a Dynamo data. The main goal of Dynamo is to provide an incrementally scalable and highly available storage system. Main goal of Dynamo is to provide an incrementally scalable. So, what are the main features of cloud computing? The very attractive feature of cloud computing is scalability. Okay, as I told you already, you know, uh, in our earlier classes, the scalability is a major point where cloud computing rely on, because in the today you wanted some 100 computers, tomorrow you wanted 1,000 computers without giving extra money, without going to the process of procuring so many systems at a time. You can just change your subscription from 100 system to 1,000 systems to any of the cloud service provider, which will support your work, and you can complete the work. Okay, so that's how it is being done. That's why scalability is very, very important and very interesting and very important factor of cloud computing. Scalable and highly available storage system. That availability is also heavy. So 24/7, the systems are available. The storage systems are available. This goal helps in achieving reliability at a massive scale, where thousands of servers and network components build on an infrastructure serving 10 million requests per day. See that it is very enormous. 10 million requests per day, 10 million connections may be there for any such data from Amazon Dynamo. So as we already said, asset properties are also taken into consideration here. Asset properties are also implemented here because Amazon takes care of all uh, factors of database, that is redundancy, duplication, that is a redundancy or duplication, or availability, or consistency, or okay, and security related issues also will be handled properly with Amazon infrastructure. So here is a Amazon Dynamo architecture given. You can go through the picture here. There is a storage peer connected as a network. Then there is a pluggable storage engine, BDB and MySQL. As I said just now, MySQL is also here available. Can understand the MySQL facility have been given here. Okay, and then failure fault tolerant mechanism has been adopted here. There is a coordinator for the request handling. There is a pluggable storage engine available to handle anybody's requirement. So these are the things available with the Amazon Dynamo. It is a collection of storage peers organized in a ring. It's connected, so it is a network attached storage or storage area network. You can call them as sharing the key space for given application. That's why all these storage systems are connected in a network. The key space is partitioned among the storage peers, and the keys are replicated across the ring, avoiding adjacent peers. Each pair is configured with access to a local storage facility where original object and replicas are stored. Also, each node provides facility for distributing the updates among the ring and to detect failures and unreachable nodes. So there may be problem where detection of failures, or whether a particular node is a member of the node, because when you are discussing with algorithms, set membership is a big question to verify membership function. No, so whether the data available in some of the storage system that can be verified with whether that storage system is a member of this ring or not can be checked with this architecture. Okay, other examples in the system are, that is Google Bigtable, Apache Cassandra, and Hadoop HBase. Okay. One minute, I'll just